First, we have some important sums of derivatives from previous year's question papers, which we will solve today. So the first question here is that we need to solve this derivative for when the value of x turns 0. Now in this case, you can see our derivatives are set in a way in a fraction. So there is a numerator and a denominator. Whenever your derivative has a numerator and denominator, or if your derivative is in a fraction form, you use the u divided by v rule to solve it. So I have written the rule down here. It is simply when you're doing u upon v, the u here is the numerator and v is the denominator. So it is simply denominator into derivative of numerator minus numerator into derivative of denominator upon denominator squared. So we will input our values into the formula. So as you can see, once the formula you start inputting the values in the form. Now once you have done that, you will get these values, because as you can see, the derivative of 2x plus 3 is only 2, since 2x is the derivative of 2x is 2 and 3 is 0. Same for 4x plus 5, you will get 4. Right? So upon further solving, you will get this 4x plus 5 into 2 minus 2x plus 3 into 4. Once you've done the required multiplication, you will get 8x minus 8x, so you can cut both of them. And the final result will be minus 2 upon 4x plus 5 square. Here you can input the value of x as 0. Once you do that, it will allow you to eliminate this 4x completely, leaving only minus 2 upon 5 square, which is your answer. So this is the derivative of x when x is equals to 0, in the case of the derivative 2x plus 3 upon 4x plus 5. Now our next sum. We need to find the derivative of x raised to tan x. So in this case, whenever you have anything in the raised to part of the derivative which does not have any traditional or orthodox formula, for example, there is no formula for x raised to tan x or x raised to any trigonometric function, what you will do is you will apply the log rule. So what the log rule does is it brings this raised to part down, right? So what you do is you use the log rule. So once you use log on this, so what you simply say is, okay, y equals x tan x, x raised to tan x. Now once you apply the log rule, what happens is this raised to part of the function comes down, so it becomes tan x, then log of the beginning of the function, which is x, so it's log x, right? Instead of if it was x raised to sin x, this would become sin x log x. So this became tan x log x. Now you get the derivative of y. So this becomes 1 upon y, and this is tan x into. So and here once again you are applying u into v, which is simply u into derivative of v plus v into derivative of u, where this first part of the equation is u and the second part of the equation is v. Upon further solving, you will reach to this, you will reach where your equation will look like this, whereupon you will take this 1 upon y, you will take this y and multiply it into the right hand side, and then you will simply substitute the value for y, which is that y equals tan x log x raised to tan x. So once you have substituted that, you have this, which is the value of the derivative. Now we need to find the derivative of x cos x. This is a very simple question sum. And the way to solve it is simply you apply the u into v rule and simplify it. Once you apply it, it will look like this, right, where x is u and cos x is v, and then once you simplify it further, you will get this, which is the answer to the sum. And now this time you have to find x e raised to sin x. So in this case, once again, we first apply the u into v rule, which will give us this. and once we simplify this part of the formula, get the derivatives, you will reach here. All you have to do after that is complete the multiplications, right, and take a common, because here you can see e raised to sin x is common. So once you take it common, you will reach here, which is the answer. Nothing further required. Now you need to find the derivative of e raised to x square tan x. So in this case, what you will do is we'll apply a rule known as the chain rule, which is simply, you know that there is no orthodox formula for e raised to x square tan x, but there is a formula for e raised to x. So what you do is you say we will take x square tan x as x. So the derivative of e raised to x is e raised to x. So we will write e raised to x. But what had we taken x as? We had taken x square tan x as x. So we will substitute the value back. So this becomes e raised to x square tan x into, we had let x square tan x as x. So now we will need to take the derivative of x square tan x as well. So simply you will say this is equals to x, resubstitute the value, and then multiply it with the derivative of the substituted value. Then here what you will do is you'll say, okay, this e x square tan x is fine, but this x square tan x, you will apply the product rule again. So u into v will be applied over here, and then once you simplify this further, you will slowly continue opening it, and after you have done that, you will get the value, which is this e raised to x square tan x. This is your final value. Now here you need to find the derivative of x with respect to y, and you have two variables given. You have x and y. So simply you are trying to find derivative of y, which is dy by dx, upon derivative of x, which is d by dx of x. So it's simply, yeah. So to find this, what you do is you get the derivative of both x and y. So you get the d by dx of x and d by dy of y, right? So what is d by dx of x, right? What is the derivative of x? So 80 square, the derivative of 80 square will be 280, right? And then you get the same for derivative of y, right, which will be 2a. So this, the top derivative is d x by dt, and this is dy by dt, right? So if you want dy by dx, you will say it is equals to dx by dt divided by dy by dt divided by dx by dt, or it is equals to dy by dt into dt by dx. So it's simply 2a divided by 2at. Once you do the necessary cancellations, the answer that you will arrive at is 1 upon t. Now you have to find the derivative of sine cube with respect to x square, right? So here you will say the derivative of sine x cube. First of all, you have to find that, and then we will find the derivative of x square, and then we'll say, okay, the derivative of sine x cube divided by derivative of x square. So the derivative of sine x cube, again we will let x as x cube as x, right, because there is no derivative of sine x cube. So we say, okay, it is equals to cos x. Then we say, but we have let x as x cube as x, so we put back the right value of x, which is x cube. Then we say, now we need to multiply this with the actual derivative of only x cube, which we had let as x, so which is 3x square. And then you will get the same way, you will get the derivative for x square, which is only 2x. After this, what will happen is you will get the value, which simply you will say, okay, it's derivative of sine x cube upon derivative of x square. And once you simplify it, you will get cos x cube into 3x upon 2. Once again, similarly, you have to find the derivative of x with respect to y. So in this case, it's a bit complex,